Hello, my name is Zichen Wang. Today, I'm presenting my real assessment project titled Predicting Customer Churn with Machine Learning. In this project, I used the technical customer churn dataset and applied logistic regression and random forest model to analyze which customer are most likely to churn and how we can predict that. My research question is, can we actually predict customer churn based on service usage and contract related information? This is highly relevant in the real world because reducing churn can significantly increase customer retention and profitability. For example, if we can identify customers likely to cancel, the business can take preventive action to retain them. I used the publicly available Telco customer churn dataset from Kaggle, which contains 7,043 customer records and 21 features. The features include contract type, payment method, streaming services, monthly charges, and so on. The target variable is churn, indicating whether a customer left last month. We treat this as a classification problem. During pre-processing, I dropped it missing values, especially in the total charges column. I mapped it yes or no feature to 1 and 0, and I scaled numerical features. Then I trained two models, logistic regression and random forest, using 80% of the data for training and 20% for testing. I used accuracy F1 score and AUC ROC for evaluation. Here we see the confusion matrix. Logistic regression performs well in predicting no churn and does a reasonably good job at predicting churn too. Random forest was slightly weaker at identifying churned customers, but overall, performance was solid. Logistic regression has a slight edge and better interpretability in practicing. These are the ROC curves for both models. Logistic regression achieved an AUC of 0.83, while random forest got 0.82. Both models performed acceptably, especially in maintaining a high true positive rate with fewer false positives. Overall, logistic regression had a slight advantage. Beyond basic train test splitting, I paid close attention to class imbalance. Only about 27% of the samples represent churn. To mitigate this, I applied class weights in logistic regression and used stratified sampling to preserve class ratios. In future work, I plan to try SMOT or focal loss for improved balance and implement k-fold cross-validation for better robustness. When deploying the model in a business context, several considerations arise. Real-time scoring requires efficient data pipelines, and model needs to be retrained periodically to adapt to changes in customer behavior. False positives might lead to unnecessary marketing incentives. Hence, the interpretability of logistic regression makes it suitable for initial deployment, while streaming data pipelines and monitoring should also be considered. This project shows that standard machine learning methods can effectively predict churn. The most influential features included tenure, contract type, and monthly charges. Limitations include static snapshot, data without time series, and class imbalance issue. For future work, I could try models like XGBoost and explore sequential modeling like RNN. That concludes my presentation. Thank you for listening. If you have any questions or suggestions, I will be happy to hear them.